नैना दे किनारे ख्वाब किन्ने सारे रखे ने सजा के हुण जी लवां उमरां दी प्यासी मेरी ये उदासी दिल करे दरिया कोई पी लवां वांग फकीरा हाँ वांग मैं फकीरा हुण वांग मैं फकीरा हाँ वांग मैं फकीरा की लभदी यारू मेरी हनेरा ना सवेरा हुण घुम्मा वांग फकीरा हाँ वांग मैं फकीरा घुम्मा वांग फकीरा हाँ वांग मैं फकीरा हाँ वांग मैं फकीरा हुण वांग मैं फकीरा अगला के रातां नूं मैं बना लिया सवेरा वे ना रिहा हनेरा वे ना रिहा हनेरा घुम्मा वांग फकीरा घुम्मा वांग फकीरा Mama Vakira, Mama Vakira, Mama Vakira, Mama Vakira, Mama Vakira, Mama Vakira. ए दुनिया दे किन्ने रूप किन्ने शहर किते चन्न किते तारे किते चढ़दी दोपहर किते बदलां दा घेरा नाले पानियां दी ले बंदे इक्को जहे दा वी किते प्यार किते वे दो मेरे कोल अखियां दो पैर छला टुर पिया गल्ला करे खुद नाल गल्ला करे जे वसदा है रब विच मेरे ओनू आखां सारे जग दा ओ भला करे मैं तां तुरना है जिथे तक राह ने जदों तक मैं हां मेरे विच साने मेले विच बैठी खुद नू तलाशा बैठा लिखा तक तीरा नाले लभदा लकीरा मैं तां तुरना है जिथे तक राह ने जदों तक मैं हां मेरे विच साने मेले विच बैठी खुद नू तलाशा बैठा लिखा तक तीरा नाल घुमावा घुमावा फकीरा हुण वांग मैं फकीरा हाँ वांग मैं की लभदी यारू मेरी हनेरा ना सवेरा घुमावा फकीरा घुमावा फकीरा हाँ वांग मैं फकीरा अगला के रातां नूं मैं वे ना रिहा हनेरा रखे ने सजा के हुण जी लवां उमरां दी प्यासी मेरी उदासी दिल करे दरिया कोई पी लवां Everybody come on! Thank you.
हम दोनों पढ़े फैज, हमें मिलते इससे फैज नहीं। जिंदगी शेर जिसमें वजन काफिया है ही नहीं। समंदर के किनारे बैठे हैं और पाँव गीले, लेके आया पानी, उन्होंने कहा आप पी लें। आप जनाब बड़े प्यार से बुलाती थी वो चली गई तो लगा प्यार करने वाला नहीं है। उसके एक सवाल पे मैं लाजवाब, आज जवाब है मेरे पास, सवाल करने वाला नहीं है। याद है पहले रोज कहा था वफा करेंगे, एक दूसरे को चाहता, तुमसे कहा था कि सॉरी नहीं करना कभी, ये दिल एक काला उसमें चोरी नहीं करना कभी। उसी जुर्म में तू आज भी रातें जागती है, पहले तू भागती थी रिप्लाई तू मांगती है। पहले तैमूर फेमस नहीं था अभी भी फेमस नहीं है, पहले तू मेरी थी सिर्फ अब तू कहीं की नहीं है। मेहरपोश में तेरी मैं सोच में, एक आवाज भी निकालती तू मुंह से। तुम मुझसे पूछती थी ताल्लुक क्या है मेरा तेरा, मैं बोलता था जो जिस्म का है रूह से। उम्र कट गई है तेरे इंतजार में, कीमत तो कीमत नहीं थी लगती हजार में। सारी बातों का सिर्फ एक ही अफसोस, दिल से निकल कर तू जा बैठी बाजार में। मेरी दास्तां को किया नहीं कबूल, मेरी वफा सारी उसके लिए फजूल। बची कोई आस नहीं तो अब इतना बता, मैंने चाहा तुझे क्या ये मेरी भूल। मेरे दिमाग में वो चल रहे हैं सवाल तेरे, मेरे जहन में क्यों आते हैं ख्याल तेरे। मायार तेरे पे मैं उतरा नहीं, तेरे लाख समझाने पर भी मैं सुधरा नहीं। मेरी गलती तो मेरी वजह, तेरी गलती तो मैं क्यों वजह। मंजिल तो पता है पर रास्ता नहीं जाने का, रास्ता ढूंढ भी लो वास्ता नहीं है जाने का। अब किसी से मेरा हिसाब नहीं है, मेरी आंखों में देख यहाँ कोई ख्वाब नहीं है। खून के घूंट पी रहा हूँ मैं रात दिन, ये मेरा खून है ये शराब नहीं है। मैं शराबी हूँ मेरी आस न छीन प्लीज, तू मेरी आस है शराब नहीं है। नोच फेंके लबों पे मैंने सवाल, ताकत शौकी है जवाब नहीं है। अब तो पंजाब भी पंजाब नहीं है, और खुद जैसा आप तो आप नहीं है। जख्म आबाद हैं आने जाने के, और ऐसा कोई भी हिसाब नहीं है।
बिखरे हुए पता नहीं क्या क्या रोज चले, तू है नहीं तो फिर है नहीं ऑन द रॉक्स चले। तू गया तो फिर मजा ही नहीं महफिलों में 9 मिलीमीटर सिर्फ गैंग टॉक चले। तुझे पता साथ मेरे लोग बहुत चले, झूठे लोग जिनके दिलों में ही खोट चले। ऑन माई ओन जोन आउट कुछ पता ही नहीं, मुझे घर पहुंचाती दुआ वरना साथ मौत चले। दिल दा दाम फिर भी जाम ढूंढता है, क्यों ये सूरज से मुखातिब क्या ये शाम ढूंढता है। वो तो रोज करे मेहनत इनाम ढूंढता है, बड़े काम किए बिना बड़ा नाम ढूंढता है। लेकिन मजा है ही थकान में, ये लफ्ज बने दर्द जैसे रहता परेशान में। गुलशन के फूल मुरझाने को पहुंचे, मैं अक्सर भूल जाता पानी डालना गुलदान में। चीजें रहती नहीं ध्यान में, स्मोकिंग टू मच धुआं भरा है मकान में। सीधी तरह बोलू करता आसान में, मैं बड़ी बातें कर ही नहीं पाता अपनी शान में। वाह भूले अपना आप हम, अक्स देखने को हमें आईने जरूरी है। सब उलझा जैसे डोर कोई, तभी कहता हूँ मुझे लाइनें जरूरी है। लिखने बैठा तो सिर्फ गम निकलाए, रूह मेरी कब्ज क्या ये दम निकलाए। मैंने जब भी मैं लिखा वो हम निकलाए, बना ये मुकद्दर जब कलम निकलाए। ये करम निकलाए हम बताते फिरे, वो सुनने के शौकीन हम गाते फिरे। गम इतने हुए हम छुपाते फिरे, तुम तोड़ते रहो हम निभाते फिरे।
आज लिखेंगे किताब फिर, कलम नाराज कहता आ गई ना याद फिर। शायर बने तेरी खातिर, वही ख्वाब वही जुर्म वही कातिल, दुनिया से आज इस तो बादल बनाते, ये तारे चमकते हम लहरें बहलाते, खो चुके अपने अपनों के लिए गाते, हर महफिल सजाते पर अंदर से आधे। आज भी लगे ऐसे जैसे मेरे साथ तू, कहते मुझे स्टार मगर मेरे लिए तो स्टार तू, बचे ना कोई यार तू जब ख्वाबों में शुमार तू, यारों का यार अपने यारों के लिए जान दूं, सबसे छोटा सबसे ज्यादा जिम्मेदारियां, जमाना रो पड़ेगा छोड़ो ये कहानियां, आंसुओं को खुद ही आंखों से छुपा लिया, समझे मैंने खुद को पत्थर का बना लिया, कंधे भारी इतने रखेगा कोई हाथ क्यों, हम डूबे तेरे पीछे केयर गिरते कोई यूं हाथ, तू इस कला पे है फख्र मगर दुनिया से नाराज हूं, ना समझे मेरी बात तो क्यों लफ्जों का मोहताज हूं, मैं तन्हा इस सहरा में जख्म ये गहरा खुद भरने दें, जब लोग ही मुनाफिक तो चेहरे से पढ़ लेते, सीढ़ी लगाते और उनको भी चढ़ने दे, बस्ती उजागर मेरे सिर गुजरने से, राहों से वाकिफ तो वापस भी करने दे, लफ्जों के ताजिर हैं सौदा तो कर लेते, हिप हॉप की खातिर हम उल्फत में मर मिटे, अदब बेनसीब ये अजब सा अदीब में, शायद खुदा के करीब में, अलग दिखता है इस भीड़ में, न रहा साया जिसके लिए देखे ख्वाब बड़े, लहू बहाया है तभी तो आज बेबाक खड़े, दिलों की ज़बान बने सोचों को आज़ाद करें, I don't wanna flow आजा जिंदगी की बात करें, सबर बड़ा कदर होती सबको बाद में, स्याही से जला देंगे कलम में इतनी आग है, मुंतज़िर इन तारों के जवाब के, जागू सारी रात में, I drink the pain away, pray for the better days, जिंदगी की जेल में, I hope that I stay the same, I'm out.
मेरे गम मेरे गुस्से पे अब हावी रहें, आंखें जागी रहें, सोचे बागी रहें, वो राहें तो नहीं रही पर हम तो हम ही है ना, हम तो तेरे हमराही हम तेरे हमराही रहे, I fuck with these words के ये खुद ही कुछ बोल दें, ये दिल की तिजोरी के बंद राज कुछ खोल दें, जहन जेल ब्रो इससे ना रिहाई मिली, सारा शहर मेरा गवाह फिर भी ना गवाही मिली, कागजों को जो स्याही मिली, कितने लोगों को मेरी जात से हौसला अफजाई मिली, थैंक गॉड खुदा बड़ा बादशाह, वो खुदा मुझे रग रग से भी जानता, मेरी सोबतों में बैठे ही नहीं जेलसी, I hope my brothers live to be everything I could never be, a bad J or D, बैठे ढूंढे दर्द की remedy, the bottle's empty and still it hurts heavily, you let it go you let it be, तो सोचो अब मैं क्या करूं, glass half full अब मैं इसमें क्या भरूं, उर्दू रैप मेरा दिल और मैं उसकी शेरगूं, नजरिए बदलते हैं यहाँ पे लड़के कू बकू, इनको क्या खबर मैं उनके हक में कितना बेहतर हूँ, एक दिन मैं लेजेंड दूसरे दिन मैं उनका दुश्मन हूँ, दोनों सूरतों में लेना पड़े मेरा नाम, मैं दोनों सूरतों में ना करूँ कभी कलाम, I'm on my own shit ये फोकस कभी टूटा नहीं, life on the edge I wanna go पर मैं कूदा नहीं, मेरे जुनून को जाहिल समझे शौक क्यों, सब कान लगाएं still nobody to talk to, सबसे यादगार रातें सबसे ज्यादा विविड, सबसे बड़े गमी देते सबसे ज्यादा हिम्मत, सबसे बड़ा नहीं हूँ घर का पर है बड़ा सबर, सब बताते मेरी माँ को मुझ पे बड़ा फख्र, like I already did not know, कितनी देखी परेशानियां फिर करम और नवाजिशें, बनावटी हम थे ही नहीं तो चूतिए भी ना बने, इंडस्ट्री मेरी दोस्त नहीं वो चाहे मुझसे ना मिले, मेरे यारों को इस सबर का सिला मिले, मैं कितना खुश किस्मत घर आऊँ वापस मामिले, ये रिश्ते वापस ना मिले जमे गफीर में जा मिले, ये भीड़ हमारे लिए थी और अब हम इसमें शामिल हैं, some days I shed tears for my peers, some days I miss whiskey with sadness and pain, I take risk जो वो कभी भी ना लें, and that's why I'm here.
ढूंढ लो मुझे, थाम लो मुझे, रोक लो मुझे, सोच लो मुझे, ढूंढ लो मुझे, थाम लो मुझे, रोक लो मुझे, सोच लो मुझे, थाम लो मुझे, रोक लो मुझे। आओगे तुम कभी मेरी जान कह रही, गाएगा ये समा, गाएगी ये समी, बदलेगा ये जहां, गाएगा आसमां। आओगे तुम कभी मेरी जान कह रही, खड़ा हूँ आज भी वहीं कि दिल फिर बेकरार है, खड़ा हूँ आज भी वहीं कि तेरा इंतजार है। छू लो जो मुझे तुम कभी, खो न जाऊं मैं रात दिन, नजरों में तुम हो बसे, कह दो जो तुम एक बार मेरे हो, बस तुम मेरे, नजरों में तुम हो बसे। खड़ा हूँ आज भी वहीं, लगी तेरी ही आस है, कैसी है ये बेबसी, ये कैसी दिल की प्यास है। छू लो जो मुझे तुम कभी, खो न जाऊं मैं।
Hi. Variables in tabular data can be classified into numerical and categorical types. Be careful to understand the differences between them and their specific types, as they play a significant role in model creation. Numerical data represents quantities that can be measured and written as numbers. The two main types are continuous and discrete data. Continuous can be understood as any number, including fractions and decimals. Example, height. Discrete data consists of whole numbers, often counting things. Example, number of people in a room. Note, variables that can potentially have infinite whole numbers are also discrete. Categorical data represents categories or groups and labels data without a numerical value. AI models fully consist of numeric operations. So, How do we feed text data? You can encode text into numbers. The easiest example is a binary example, like gender. You can just assign 0 to a male and 1 to a female and use those numbers in model training. This is a common practice and is always used for encoding binary variables. But what if we have 4 categories? There is an important point here. Categories can be either ordinal or nominal, meaning that they either can have an order or be unordered. For instance, you can have very bad, bad, good, and very good, which is ordinal data. These categories have an order or ranking. We can confidently map them to numbers. But what if we have colors? Red, blue, green, and orange. Models in AI assume that the numerical values have a meaningful relationship, meaning 0 is smaller than 1, 1 is smaller than 2, etc. For encoding nominal, unordered data, you need a technique called one-hot encoding. One-hot encoding creates a separate column for each category and contains a 1 if the category is present and a 0 if it is not. It simply creates binary variables from each category. Now you may ask, what if I have 1,000 unique categories? My dataset will have more than 1,000 columns. These are important questions to be answered in the upcoming videos, so subscribe to stay updated. If you want to learn more about artificial intelligence,
So I'm going to talk about text embeddings. Maybe you've heard of them, maybe you haven't. This is something I'm really excited about, but I feel like doesn't get enough attention these days. But before getting into that, you might be wondering, who is this guy? Why should I listen to him? It's a good question. A little bit of background about me. 6 years ago, I was getting my PhD at UT Dallas. That's when I first got into AI. I was an applied AI researcher. Then I worked at Toyota. I was a data scientist there. Then after about a year, I went out on my own to become an entrepreneur, which means a lot of different things. So I did AI consulting, post a lot of content. Like Yeshika mentioned, I have a YouTube channel where I post a lot of educational videos on AI. I also started a boot camp called the AI Builders Boot Camp. Had over 100 students in there. And I even took a crack at AI product development where I got a whopping 1 customer. All right, so let's talk about text embeddings. The motivation for this is that there's a big problem with text, which is you can't do math with it. For example, let's say you go to a networking event or you network after this presentation here. If you're trying to summarize or analyze the different ages of the people taking the summer school with Dallas AI, that would be a pretty easy thing to do. You can write down everyone's age, you can compute things like a mean, a standard deviation, you could plot a histogram, you could derive bins to put people into different segments. So that's a pretty easy thing to do because age can be represented with numbers. But what if you wanted to analyze people's job titles? That's not something you can really do directly. You're probably gonna have to read it and then manually come up with categories or something like that. So this is what text embeddings can help us with. And simply, text embeddings translate words into numbers. So we could take these job titles and we can translate them into these text embeddings. So these just numerical representations. But these aren't just random numbers. These are meaningful. They're semantically meaningful numbers. What I mean by that is if we were to generate these text embeddings and visualize them on a 2D plot, we would get something like this, where the engineers tend to be close to each other. So green is a machine learning engineer. This orange is an NLP engineer. We have a researcher over here. We have students over here, so a computer science student, AI student, so they're clustered together. And then we have others, so that's applied ML specialist, a data scientist, and an AI product manager. So text embeddings allow us to make text computable, and this unlocks a whole set of use cases. But you might be wondering, can I just use ChatGPT for this kind of stuff? Dump all the job titles to ChatGPT and say, hey, come up with categories, help me analyze this. Well, you can definitely do that. It's just important to understand the pros and cons between large language models and embedding models. Starting with LLMs, great pro of this is that they can perform the task directly. With LLMs, you just dump all the text you wanted to analyze in natural language, say what you want it to do. Also, LLMs are typically bigger and more capable than the embedding models. LLMs might be hundreds of billions of parameters, while embedding models are hundreds of millions of parameters, so like 3 orders of magnitude in parameter size. But there's some downsides. So bigger and more capable, that also means it's more expensive. It takes more time to process information, costs more money, especially if you're making API calls to OpenAI. It's limited by its context window. After maybe a few hundred job titles, ChatGPT might start having some issues in its ability to do the analysis. And the responses are unpredictable. LLMs are stochastic systems, and you're going to be sampling tokens one at a time in this stochastic way. So you can imagine it's like rolling dice one at a time and trying to get a very predictable sequence of numbers. Embeddings, on the other hand, the downside is it's going to require some downstream analysis. Since the embedding model is just giving you numbers, it doesn't really answer your question or solve solve your problem. You're gonna have to do some additional analysis once you have the embeddings. Also, they're gonna be smaller and less capable, but that also comes with the upside that these are gonna be like 100 or even 1,000 times cheaper than using a large language model, which means faster. You can deploy to an edge device or something like that. It's applicable to big data sets because you don't have to fit all the text you're trying to analyze into the model's context window all at once. You can do it one record at a time. You can have billions of job titles being processed by this system. And the output is deterministic. So embedding models, any text you give into it, it's going to have the same numerical output every single time. What this unlocks is all the traditional machine learning and statistical tools that we've had for the past 100 years or so. So we can do things like text classification. We can embed emails, figure out which ones are spam and which ones are not spam. We can do clustering, so we can do something like customer segmentation, get a bunch of customer data, and find natural clusters. And then we can do regression. So let's say you have support tickets coming in, and then you can generate embeddings for them and try to predict the estimated handle time for that ticket. Let's walk through a code example. This is real data, it's a real use case, and so this is a big problem that I'm facing, is that I have this class called the AI Builders Bootcamp, but I don't know who my ideal customer is, which is a big problem for a business. Because if you don't know who your customer is, how do you know how to position your product or service? How do you know how to write your copy on your landing page? How do you know what marketing channels to go after? It's a really big problem for businesses, especially me. I have all this data though. I have people's job titles, and I have the reason why they joined the course. So I have a diverse range of job titles and join reasons, but which one of these segments, which one of these groups are my ideal customer? This is something I'm going to try to solve with text embeddings. The solution is I'm going to use this student data to predict the probability that someone will leave a 5-star review for the class. Here's the basic flowchart of what we're going to do. We're going to load in the student data with pandas. We're going to embed the join reasons and the job titles using OpenAI's API. Then I'm going to use sklearn, so traditional ML here, to reduce the dimensionality
Hey, what's up guys? Welcome back to another machine learning video. In this video, I'm going to teach you how to do feature scaling. This is another very important step to pre-processing your dataset for machine learning. Let's jump right into it. So here's an example of two feature columns that you might see in a dataset. Clearly, if you just take a look here, the two numbers range very differently. So on the left here for feature A, you have 5 to 25. But for feature B, you have 20,000 to 50,000. They clearly have a very different range of numbers. That's not good because some machine learning algorithms will interpret the data in a way where the second column, because it has a much larger range, will overpower the first. Therefore, we need to employ something called feature scaling, which simply means that we have to have all the features of our dataset on the same scale or in a consistent value range, but at the same time maintaining their meaning. So there are two major methods to feature scaling. You have normalization and standardization. Normalization, also known as min-max scaling, will shift and scale the values within the features to a range of 0 to 1, or for example, -1 to 1. You can actually customize the range when you use something like the min-max scaler from scikit-learn, but the default is going to be 0 to 1. So this means that every single value in that column, or all columns that you apply this to, will be within that 0 to 1 range. So here's the actual formula that you can use to calculate every single value. So you have the new x is going to be equal to the original x minus minus the minimum x over the max x minus the minimum x. And the minimum and the maximum are just the minimum values within the entire column or feature. So applying this formula across every single value in a column will give you that range I told you about. Standardization, also known as z-score normalization, will use a different formula down here to transform the data to have a mean of 0 and also a standard deviation of 1. So this formula is the new x is equal to the original x minus the mean divided by the standard deviation. Both of these here will do feature scaling for you. They differ in how it works and also in what situations you should probably use one of these two. So here's what the data could look like after it's standardized and normalized. So if we have this input column 0, 1, 2, 3, 4, 5, if we standardize it, this will be what the values can look like. So you can see it's also going in the negative direction now. But they're much smaller, so in a much smaller range. And then if we normalize it, this is what the values will look like if we do it from 0 to 1. And of course, this is only showing one column just to illustrate how the data would look like. But the whole point of feature scaling as well is to make sure that all the feature columns are standardized, or feature scaled rather, to the same range of numbers. That way certain columns do not overpower other columns, okay? So the main question you may have is, what is the difference between normalization and standardization, and in what situations should you use either one? Here's a little table that I found that shows you the major differences that you can just take a look at here. So for normalization, it rescales the values to range between 0 and 1, by default at least. It's useful when the distribution of the data is unknown or not Gaussian. I think I'm saying that correctly, hopefully. Normalization is also sensitive to something called outliers, which are values that fall out the normal range of values in your dataset. It retains the shape of the original distribution. It may not preserve the relationships between the data points, and the equation is different, of course. Standardization centers the data around the mean and then scales it to a standard deviation of 1. It's useful when the distribution of the data is Gaussian or unknown, so in either situation you could use it when it's unknown. It's less sensitive to outliers because of the way that it works. It changes the shape of the original distribution, it preserves the relationships between the data points, and it has a different equation. Now, of course, I could go way deeper into this. I could really dive into the differences between the distributions and all that stuff, and I don't really want to do that. I want to keep it as high level as possible. This is a machine learning fundamentals, series. But as a general rule, what I've seen online is basically just the easiest thing that you could do is really just do both of them. Run both of these on your data set, and then run it through a machine learning algorithm and just see how they compare. That's one naive approach that you could do if you don't really know the distribution of your data, you don't know how many outliers you have and stuff like that. It's a really simple way to, get started. If you do, however, know that it has outliers and it's Gaussian and all that stuff, you can choose a specific option if you want to. Some other books that I've read says that you should also use standardization by default. It's a good approach because it does preserve the relationships between the data points. It is less sensitive to outliers and all that stuff. So the main point of this video though is to tell you what is feature scaling and the two different methods that you can do to do feature scaling. And then in future episodes, we'll decide whether to use normalization or standardization when we learn about future models, okay? And with that said, now that we know what feature scaling is and how to do it, what formulas we can use, let's go ahead and jump into the code now and see how we can actually do it. Alright, so I've got a Colab notebook opened up here. I've created it. And I've also got a data frame that will hold some sample data that we can work with to test out feature scaling. So let me go ahead and run this. So here's what our data looks like. We have 3 columns. We have the age column that ranges from 5 to 30, pretty low numbers here. Then we have the IQ column, which ranges from like 20,000 to 60,000. So we've got much larger numbers here. And then I have a target column that represents our target variable. So these are just random numbers here. We can pretty much ignore this column completely because we're going to be focusing on feature scaling our feature columns here. So you can clearly see that these 2 columns here have much different ranges. So this IQ column here, when fed into a machine learning model, possibly can overpower the age column. So what we want to do is scale them down to the same range, which is of course feature scaling. Now feature scaling is done after you have split your data set into a training set and a test set. So let's go ahead and do that. So x is equal to data.il ranges. So this IQ column here, when fed into a machine learning model, possibly can overpower the age column. So what we want to do is scale them down to the same range, which is of course feature scaling. Now feature scaling is done after you have split your data set into a training set and a test set. So let's go ahead and do that. So x is equal to data.iloc. We want all rows and then everything but the last column. And then y is equal to data.iloc, all rows, and then only the last column. Now we want to split our data into a training set and a testing set. So we're going to do from sklearn.model_selection import train test split. And this function allows us to do all that. So we want an x train set, we want a x test set, we want the y train, and we want the y test. That's going to be equal to train test split. We're going to pass in our x, going to pass in our y. We're going to specify the test size, which is going to be 0.2. So 20% of our data set will be used for testing, and then the other 80% will be used for training the model. And then we're going to use a random state of 1, which just again makes it so that we get the same result every single time that we run this here. Okay, so we're going to run this now. So now we should have our x and y split up into a training set and a test set for each of them. So x train, x test, y train, and y test. Let's just go and print out our x train just to get a look at what it looks like here. All right, so we get our two columns here, age and IQ. So 25, 5, 20, 30, 60,000, 20,000, 25,000, and 50,000. So now we can go ahead and do feature scaling. So we learned about before that there's two different types of ways to do feature scaling with your data set. That's normalization and then standardization. The first one that I'm going to show you is normalization. So to do that, we're going to do from sklearn.preprocessing import min.
Hello everyone, and welcome to this new video on feature scaling. Today, we will learn about the difference between normalization and standardization. Let's go ahead and get started. So feature scaling is an important task or step that we do prior to training of any machine learning models. And the objective is to ensure that all features that we have in our data have the same scale. So let's take a look at the practical example. Let's assume that here I have raw original data set, and this data set contains three columns. These are interest rates, employment score, and S&P 500. So if you guys kind of scan through the data, you would notice that the range or the scale of that data is just completely different. Interest rates here, if you take a look at that quick stat or the statistical summary about my data, you will notice that the minimum value here of the interest rates is between 1.5 and the maximum is around 3. If you check out the employment, which is again, this is not employment percentage per se, it's an employment score. Just score that indicates how powerful the stock market is, how strong it is. So if you check out the employment, you will notice that the minimum is 40 and the maximum is 70, and the S&P 500 between $1,800 and $3,000. So basically, if I decided to go and train an AI model or a machine learning model basically with this data, I need to make sure that all the data sets, all the features are scaled. They have the same scale. So basically, I'm not going to have one feature that dominates the other feature. So to do that, we are going to cover two different techniques or strategies. So the first strategy is what we call it normalization. So normalization is conducted to ensure that features could range between 0 and 1. So all I'm looking for is to go back here and take a look at the interest rates, employment, S&P 500, and just make sure that all of them range between 0 and 1. So min-max values here would be 0, 1, 0, 1, 0, 1. That's the objective. So let's learn how we can actually calculate that. So to do that, this is simply the equation. I'm going to get any number. I'm going to subtract the minimum value, and then I'm going to divide by the maximum minus min. So x minus x min, divide by x max minus x min, and that is going to give me the updated or normalized value. So luckily, I don't want to go and actually write like a large code, large lines of code that contains or kind of perform that process or even write this equation. All I need to do is to basically leverage a library known as scikit-learn library. And if you guys hang in there until the end of the video, I'm going to show you a detailed video explanation where we're going to walk you through an actual code that performs the exact same process here in scikit-learn. So these are simply how the three lines of code where we can use them to perform what we call it min-max scalar. So min-max scalar is simply normalization. So what we do first is we say from sklearn.preprocessing, I'm going to import my min-max scalar class, and then I instantiate an object out of my class. I say scalar equals to min-max scalar, and then I grab that object, apply the fit transform method on it, pass it along the data, and that data here is going to be stock_df, which stands for data frame. And then I'm going to override that data and just generate a normalized or scaled output. Okay, so let's take a look at an output and an actual example from a normalization process. So if you guys see here I have my pair plot. This is simply the different scatter plots between employment and S&P 500, and essentially with every feature that I have in my data. So after you perform normalization, so here this is the raw data, this is the normalized data. What you guys notice is the range, kind of the scale of my data is completely different now. Now employment used to range between 40 and 70, now it ranges between 0 and 1. If you check out interest rates, same deal. Interest rates used to be between 1.5 and 3, and now it's between 0 and 1. So essentially, if you take a look at the normalization process output, all what I'm doing is I'm scaling my data to range between 0 and 1. If you take a look at the statistical summary of the data, you will notice that here I had the minimum value of the interest rate was 1.5, maximum was 3. If you check out interest rates, now it's between 0 and 1. Same deal as well for employment, it's between 0 and 1, and S&P 500 between 0 and 1. And that's the main objective of the normalization process. So let me show you an actual example where we go and actually substitute in this equation, kind of go through a bunch of runs. So what I'm going to do is I'm going to use 4 sample data points. I'm going to grab, again, that's from the raw data. I'm going to grab a random number, that will be 2206. I'm going to grab the average value. I'm going to grab the maximum and the minimum. Okay, so these again I've been able to obtain from that table, right? And let's go ahead and let's pick maybe that randomly selected number, which is 2206, and go and substitute in this equation. So if I substitute in this equation, you will notice that 2206 minus the minimum value, which is 1800, divided by maximum minus minimum, which is again 3000 minus 1800. And what I'm going to get is 0.338. So I'm going to go here and put that value here. So 2206 in the raw data has an equivalent of 0.338 in that scaled or normalized version of that data. What if I substitute the average? Well, if you take the average, put it here, again run through it, you will end up with 0.432. If you grab the maximum value, which is 3000, and you substitute here, you will notice that the value here, the normalized value will be 1. If you grab the 1800 and you put 1800 here, 1800 minus 1800 will be 0, and that's why you will get 0 here in the output. So basically, again, the objective of the normalization process is to transform the min-max value from whatever number that is to be between 0 and 1. And that's what I'm getting here, and I was able to confirm that, again, by substituting in this equation. Okay, what about standardization? Well, standardization is conducted to transform the data to have a mean of 0 and a standard deviation of 1. Please note that this is drastically different compared to normalization, which is what we covered before. And standardization process as well is known as what we call it the Z-score normalization. And essentially we try to shift our data to have an average or a mean of 0 and standard deviation of 1. Okay, so what about the equation? The equation is simple. I simply get any data point, I subtract the average, so this is the average or the mean value of my distribution of my data, and then divided by the sigma, which is my standard deviation. So here, if you go ahead and see how we can actually perform that in scikit-learn library, I'm going to do the following. I'm going to say from sklearn.preprocessing, I'm going to import standard scalar, and then I'm going to instantiate an object here. So I'm going to say scalar equals to standard scalar, and then I'm going to apply the fit transform method on my object, pass it along the old data or the raw data to generate a brand new data set, and that is going to be my standardized data set. So let's take a look at an actual example. So what you guys see here on the left-hand side, that's again the raw data. On the right-hand side here, that's the standardized data after we did the transformation. So what you guys notice is here, the raw data for employment, for example, range between 40 and 70. In the standardized form, it ranges between minus like 3 and 3, somewhere along those lines. And this is quite important. When we perform the standardization process, we don't care about the min and max value. We care about the average of the distribution or the mean of the distribution and the standard deviation of that distribution. So what you guys notice here is if you check out or kind of plot the statistical summary about my data, you will notice that here the average was 2.2 in my raw data. In my updated standardized form, it becomes everywhere becomes 0. All the mean becomes 0. If I get the standard deviation, well, the standard deviation becomes, all of them becomes 1. And that's exactly what I'm looking for. So let's take a look at an actual example to kind of go again, select 4 random points and just go and substitute in this equation. So here I have a randomly selected value of 2206. If I substitute 2206 minus 2319 divided by 193, I will end up with 0.583. I'm just going to put it here. If I grab the average value, which is 2319, and I substitute in this equation, 2319 minus 2319, which is the mean, I will get 0. And that's the overall intent here. The idea is the output here was going to be 0. Okay? And of course, the maximum value could be anything. It could be 3.5 here, for example, and the minimum is going to be minus 2.67. So always remember, kind of the key takeaway is a normalized data set will always range between 0 and 1. However, a standardized data set will always have a mean of 0 and standard deviation of 1, but it can have any upper and lower values. Okay, we don't really care about the upper and lower values. We care about the average, or the mean will be 0. Standard deviation, or the dispersion away from the mean, is going to be 1. Okay, so now to the big question. Okay, when should I use standardization versus normalization? Why do I even need it? Well, so scaling, which includes standardization and normalization, or normalization per se, is required when you use any machine learning algorithm that requires you to calculate the gradient. So if basically when we train any machine learning model, let's say an artificial neural network, in order to update the network weights, I need to calculate the error and I need to propagate the error back, okay, using the gradients essentially to update my weights. And whenever I do that, I need to make sure that I'm performing the scaling. And the reason is because I'm calculating that gradient, I wanted to make sure that all the features have the same scale, so I won't have a feature that will dominate the other feature. Okay? And okay, what examples, for example, can you share with me examples? Well, I have linear regression, logistic regression, artificial neural networks, deep neural networks. Neural networks, all of that will require you to calculate the gradient. And if you require that, you need to make sure that as part of the pre-processing phase that you're running or performing standardization or normalization. Please note that scaling is actually not really required when you perform distance-based or tree-based algorithms. For example, if you're using k-means clustering, if you're using support vector machines, if you're doing k-nearest neighbors, decision trees, random forest, XGBoost, all these algorithms, which are distance-based and kind of or tree-based algorithms, we don't really need to calculate the gradient, so we don't care about standardization or normalization. You can just go ahead and run the algorithm. All right, so when to use standardization versus normalization? So generally speaking, there is no right or wrong answer when it comes to that. In case of artificial neural networks, for example, normalization is preferred since we don't assume any data distribution beforehand. So in general, standardization is preferred when data follows a Gaussian distribution. So if you have data that follows Gaussian distribution, it's better, kind of again, general guideline to use standardization. And standardization is preferred over normalization when there are a lot of outliers in the data. Okay? All right, so what I'm gonna do next is I'm gonna go ahead and shift to the Jupyter Notebook and show you guys a detailed code where we are going to grab data set and perform standardization and normalization on it from scratch. Again, if you guys like this video so far, I would really appreciate it if you just give it a like and subscribe as well for more videos. Let's go ahead and get started. All right, so here we go. Now I have my Jupyter notebook, and here I have the standardization versus normalization basically process. First, I'm going to go ahead and import all our key libraries and data sets. So first, I'm going to
साथी अब दुःखको भारी बिसाइदे तेरो तातेको टाउकोमा थोरै पानी मिसाइदे ऐना हेर्चा त्यसमा देखेको चोरलाई जिस्काइदे एउटा बोतलमा पानी बोक अनि पुरै रित्ताइदे हिजोको झगडा अनि आजको घण्टा जस्तो दिन त्यो हेक्टिक सेरो तेरो फुर्सद छैन एकछिन त्यो अनेक थरीको टेन्सन अनि के हो के भयो छोड्दे लामो सास फेर मजाले एक सेकेन्ड त्यो कुचेको मुखलाई एकछिन खुलाएर हाँस्न पुरै जिन्दगी बाँकी छ एकछिन रमाएर बाँच्न तेरो दुखेको जिउ अनि थाकेको खुट्टा गनाउने मोजा फाल्दै साइडमा पर्दैन बोन लुका अनि बस आँखा बन्द गर्दै फोनलाई पनि फालिदेन हेर त कसको फोन आयो छोड्दै काटिदेन सल्काउने कि एक सरको प्याकेट खोल्दै बालिदेन भित्रसम्म तान अनि माथि हेर्दै फालिदेन हेर त आकाश कस्तो निलो अनि बादलको त्यो टुक्रा त्यो हाँसिरहेको सूर्य अनि उडिरहेको चरा त्यो चिसो चिसो हावा अनि हरियो हरियो रुख त्यो सब देख्दा पनि किन उदास तेरो मुख तेरो बाउले किचकिच गर्यो गर्लफ्रेन्डले छोड्यो झगडा पर्यो कि आफन्त कुनै मर्यो तर यति कुरा बुझ्न अझै हुनु छ भयो तेरो हातमा के छ र साले बेकार ठस्स पर्यो 2 दिनको जिन्दगी छ एक दिन हिजै बितिसक्यो आजको के बढ्छ र सोच त दिउँसो भइसक्यो त्यसैले दुःख बिर्सिदे रिसलाई पनि किल्चिदे पहेँलो दाँत देखाउँदै खुसी हुँदै हिँडिदे के रिस के राग त्यसलाई साइड लगाइदेन अरूको गल्ती भए पनि माफी मागिदेन अनि हेर तेरो जिन्दगी कति सुन्दर देखिन्छ त सबैको हुन्छ सबै तेरो भइदिन्छ Lay down तेरो टाउको भुइँमा राख्रे आकाशतिर हेर अनि सपना बुन्न थाल्रे त्यो चम्किरहेको तारा तेरो भविष्य हो सफलताले चुम्छ त्यसलाई अघि बढिरहन्छ जो त्यसैले बढ अघि बढ सधैँ खोला जस्तो भएर बाँच्यो जिन्दगीलाई हटेर होइन डटेर तेरै हातमा सब थोक छ समात्न मात्र सिक नबस सक्दिन भनेर जुरुक्क उठेर हिँड जिन्दगी कति कठोर छ यो समाज कति छुच्चो कुरा काट्नेको मुखमा हामीले लगाउनु छ बुझो गर्नु छ केही बन्नु छ हुनु छ सधैँ अगाडि राम्रो गर्नु छ सबैलाई राम्रो बाटो समाति तसँग के छैन होइन के चाहिँ छ भनी हेर्ने निराशामा डुब्नु भन्दा आशावादी हुनुपर्छ हामीले तँलाई अरू पर्फेक्ट छ आफू छैन जस्तो लाग्छ सोच त साले चन्द्रमामा पनि कति धेरै दाग छ म तैरिरहेछु पानी माथि काठको टुक्रा जस्तो अर्थहीन जिन्दगी छ काठको मुडा जस्तो निस्तेज छु म गर्मी मासको हावा चाहिँ संसार नै खल्लो चिनी नभएको चिया चाहिँ जित्ने सोच कति थियो तर केमा हारिन र सानो उमेरदेखि नै के गल्ती गरिन र म त खरा मान्छे पुरिएको अपराधमा तर भगवान बस्नुहुन्छ मेरो अन्तरात्मामा थाहा छ हरेक कालो रात पछि बिहानी आउनेछ अबोध बाल्यकाल हटाउन हरियाली जवानी आउनेछ जवानीमा जे गरे पनि पछि बुढो हुने हो मैले गरेको सबै कर्म मसँग रहने हो जानेछु म कुनै दिन आँसुको प्याला पिउँदै गर्न सकिन केही राम्रो जब थिएँ म जिउँदै जब मेरा हात चल्थे जब शरीर बलियो थियो तब माग्ने छु क्षमा हे भगवान गल्ती भयो म जब खुसी थिएँ तब हजुरको याद आएन हाम्रो पुर्खाले दिएको अमूल्य संस्कार मानिन बाउनको
to import pandas, as pandas is primarily used